Hi everyone, I'm Lutz Hofmann. I'm a PhD student with the Visual Computing Group at Heidelberg University, and I am the author of the TTK Conda package. I will be talking about how to use TTK with Python. So TTK is organized in these three layers, where at the bottom we have some pure C++ code, which is then wrapped into the VTK algorithm API, which is then exposed to ParaView using some additional XML definitions. ParaView comes with its own Python interface, which is also called PBPython, and VTK also provides a Python interface, which I will be mainly talking about. But first I would like to explain the difference between the two Python interfaces. As a simple example, let's say we have some VTK unstructured grid where we would like to execute a TTK manifold check on. Now if we use the ParaView Python interface, we would first need to get our data into the pipeline. And this can be done by creating a trivial producer and attaching our input data to its client-side object. And this, however, only works if we are connected to the ParaView built-in server. It will not work if we are connected to some remote server. Once we have our data as a source in the ParaView pipeline, we can then execute the TTK manifold check ParaView filter on it, and finally also get the result out of the pipeline again using server manager fetch. This, however, will create a copy of the data. Now if we use the VTK Python interface, on the other hand, we can directly access the VTK layer, so we can just create our TTK manifold check algorithm directly, set our input data, execute it, and also similarly directly access the output object. To summarize, the ParaView Python interface modifies some global state, which is the ParaView pipeline, and it operates on the client-server architecture, while the VTK Python interface accesses the VTK layer directly, but comes with a more verbose syntax. Both of these interfaces have their own use cases. So the ParaView Python interface is useful for automating ParaView workflow, and there's also this nice feature that you can export a ParaView state as a Python script. The VTK Python interface offers a lot of more freedom, and for example it can be used to create your own custom user interfaces, and it also offers a useful NumPy interface, which I will talk about later, and it can also be useful within ParaView itself, which I will also come back to later. So for installing the TTK Python module, the easiest way is using Conda. So there's a package called Topology Toolkit provided through the Conda Forge channel, and this should just work on the major platforms. Of course, you could also build TTK from source, which will then automatically detect if your VTK or ParaView installation has Python support enabled. If you would like to use the Python module from the TTK build tree, you need to additionally export a Python path to make the path to the Python module known to Python. So let's talk about the VTK Python interface. This interface is automatically generated from the C++ interface, which causes the VTK Python code to look very similar to C++ code. In fact, in this example that you can also find in the TTK source, I simply replaced all the arrows in the C++ code with dots in order to obtain the Python code. Now in ParaView, it would now be very simple to obtain a visualization of this computation. However, since we are now at the VTK layer, we would need to build our own rendering pipeline in VTK from scratch, which would generally take a few hundred lines of code. However, we can of course also use other VTK-based modules, such as PyVista, together with the TTK Python module. And PyVista provides a very simple API in order to get VTK rendering. VTK also comes with a NumPy interface, and this allows you to wrap data that is stored in some NumPy arrays into VTK arrays. So for example, we could define a triangular mesh like here, where we define the triangles as the rows in this array here. We define some positions also as rows in an array, and we additionally need to define offsets which give the index to the first element of each triangle in the flattened connectivity array. This is mainly used for VTK, and we can then use these NumPy arrays and wrap them into VTK data arrays, and here only the pointers to the underlying data of the NumPy arrays are copied. And with this VTK NumPy interface, we can now construct a VTK unstructured grid that itself holds no data, but all data is stored in these NumPy arrays. Since we now have a VTK object, we can apply our TDK manifold check on it, and we can get the output again as a NumPy array. And now this NumPy array also holds no data itself, but it simply contains the pointer from the underlying data that is stored in the output object of this manifold check algorithm. So this provides an efficient way to access your data from within NumPy or VTK, but you need to take care that the objects that own the memory are kept alive for long enough, since there's no reference counting done here. Finally, I would like to point out that the VTK Python interface is also useful in ParaView, namely if you use a programmable filter or a Python plugin. So Python plugin is basically just a newer version of the programmable filter where you implement a VTK Python algorithm base class in a Python file, which can then be loaded directly as a plugin in ParaView. And now in this programmable filter or Python plugin, you of course cannot use the paraview.simple API, because this would modify the pipeline while the pipeline executes, and it will have some unexpected results. So here you need to use this VTK layer, and as a byproduct, these will also work when you're connected to a remote server. So to conclude my talk, the TDK Python module can be easily installed using Conda. You should try it. And I would also like to point you to the Conda Forge repository, which contains the source code for building the Conda package. And if you find a bug or you would like to contribute to the packaging, then you are welcome to open an issue or a pull request in this repository. Thank you for your attention.